Good morning, students. Today we are going to see numerical differentiation, its application, and today we are going to see backward formulae, okay, to find out the derivative of the given function in the tabular form at a value x which lies at the end of the data, okay. Can you hear me?
Yes, ma'am.
Okay, okay. So, yeah, let us solve the problem. Now find the first question. Find the first and second derivative. First and second derivative at x equal to 1.5. Okay. And your values are, x values are 0, 0.5, 1, 1.5 and 2. And your y values are 0.3989, 0.3521, 0.2420, 0.1295 and 0.0540. Have you written the values?
Yes, ma'am.
Okay, so this value 1.5, if you observe, this value lies in the table, right? It is actually there in the table. So our job becomes very easy. Okay, we will set this value as our xn. Right now, what is the value of xn in the original table? 2. But as we want to find out the derivative at x equal to 1.5, which is at the end of the table, so we will be using backward differentiation formula. But as 1.5 lies in the table, we will call or we will treat it as our xn. Okay, so that u becomes 0 and we will use that formula after substituting u equal to 0. So let us first prepare the backward difference table. Okay, backward difference table. So del y, the first cell would be empty. Yes, 0.3521. You have to keep the same direction. 0.3521 minus 0.3989. So what is the answer? It is minus 0.0468. Okay, 0.0468. Then next is minus 0.1101. You should verify these answers. This is a solved problem I am taking purposely so that we can cross check our answers. Okay, so you please verify whether these entries are correct or not. Then next is 0.1125 and minus 0.0755. Okay, next is del square y. Are you getting the same answers?
Yes, ma'am. Yes, ma'am.
Oh, yeah, what is the first one now? This is again minus or plus? This will become minus or plus minus 0.1101 minus 0.0468. So that will
Minus 0.0633.
minus 0.0633. Yes. Next would be again minus 0.0024. And the last one, it is positive or negative? The last one, is positive or negative?
Positive.
Zero point
0.037.
357.
0.037. Then next, del cube y. Yes. So what is this minus this? So 0.06,
0.0609.
0.0609.
0609.
And the last one 0.0394. Correct? That will become plus.
Yes, ma'am.
That will become plus. So it will increase. And the last one, it is minus 0.0215.
0215.
Yes, all of you please write down that minus sign. There is no space for me. Okay, I will just manage it somehow. It is minus 0.0215. Just a minute. Today, our TYBSc and MSc students have their results. So they Yes, girls. So now tell me, you can see 1.5 lies in the table actually, right? So we will consider the corresponding. Uh, Let me just find my cursor. Yeah. Do you see this 1.5? We will set this as xn. Do you hear me, girls?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
This value we are going to set as xn. So what will be this? इस डिफरेंस को क्या कॉल करोगे आप? See, this is my xn, so this is my yn, right? Correct?
Yes, ma'am.
So this will
Yes, ma'am.
become my del yn, correct? This will become my del square yn, and this will become my del cube yn, and there is no del raised to 4 yn for this x 1.5 value. Do you understand this? So we will be making use of this entire row. Okay, this row we are going to use only. I hope you are understanding what I am saying. 1.5 lies in the table. It is at the end of the table. Therefore, I am setting xn is equal to 1.5. Okay. Have you written all these differences? Can we go to the next page?
Yes, ma'am.
Okay. So now as I will write as 1.5 lies in the table at the end of the data, we set xn is equal to 1.5. And therefore, what will happen to your u? What is u ka formula? X minus xn. We said x is equal to xn. Okay. So 1.5 minus 1.5 upon zero point 0.5, that is equal to 0. Okay. Are you getting it? We are setting x equal to xn is equal to 1.5. So both are equal and therefore u value becomes 0. Okay. So now which formula you will use? Tell me to find dy by dx.
dy by dx equals to xn.
Dy by dx. So therefore dy by dx at x equal to xn is equal to 1 upon h into bracket del yn plus half del square yn plus 1 by 3 del cube yn. Do you have del raised to 4 yn here?
No, ma'am.
You don't have. So you
No,
will
ma'am.
stop writing the formula also. And if you write the correct formula like this, you will get 1 mark. What is h value?
Ma'am, in the formula, we have to write it not till del raised to 4 yn, but while substituting it will become 0, no?
What will become 0? Now del 4.
Ma'am, in the form,
In while deriving it, we had written up to del raised to 4. That is a general way of writing the formula. But here you
so
can
ma'am, now,
here you can stop because you don't have del raised to 4 yn for 1.5. For 1.5 Vipashini. For 2, for the value 2, you have del raised to 4 yn. Okay, but we are talking specially about 1.5. So up to which order you are getting backward differences for 1.5?
del cube y.
So you should write the formula up to that only, otherwise you will only get confused. Okay, that you have written del raised to 4 yn and why you are not substituting it. Do you understand me? You can write plus
Yes,
dot
ma'am.
dot also, plus dot dot करके formula कर सकते हो. But why to confuse ourselves unnecessarily? What is del yn now? It is minus
Minus
0.1125 minus 0.1125 plus half into bracket minus 0.0024 minus 0.0024 plus one third into bracket 0.0609. Okay, please do this calculation quickly and tell me the answer.
Minus 0.1868.
Minus 0.1868. Correct. Please note it. Yes, finished writing. Now we want second
Yes,
derivative.
ma'am.
What is second derivative formula? d2y upon dx square. Again at x equal to xn, or here you can specify actually. What is your x value now? 1.5. So you can actually write down 1.5 value at the bottom. Now what is the formula for d2y by dx square? I will
1 upon
just make a correction in writing. This is xn, and now when you actually substitute the formula values, here you can write x equal to 1.5. Here I am writing xn. Now tell me the formula. 1 upon h square
h
into
square
bracket.
del square yn
Hmm,
plus del cube yn
okay. And there
plus
are some more
yeah,
terms, but we should not include them as our differences go up to only del cube. Do you understand it?
Yes, ma'am.
Huh. Finished writing. Can we go to the next page? हो गया क्या? Therefore, d2y upon dx square at which value you are finding 1.5 is 1 upon zero point 0.5 square into bracket. What is del square yn? What is del square yn? This is del square yn minus 0.0024 minus 0.0024 plus del cube yn is 0.0609. So what is the final answer? Tell me. Tell me the final answer.
0.117.
Huh?
0.117.
No.
ma'am 0.234
0.234. It is 1 upon 0.5 square, Bipashini. So 1.5, 1 upon 0.5 square. So that is 0.25. So that will
Yes,
become
ma'am.
100 upon 25, na? And in the bracket it will be 9 minus 4 is 5, 16.
Ma'am, it is 0.0585.
5?
85.
Huh. So
0.234.
okay, it is 0.234. Yeah. Okay, have you understood it? Let
Yes,
us
ma'am.
let us quickly go back. See, we will summarize the problem. We want to find out first and second derivative at 1.5. So 1.5 value, it is actually given in the table, and therefore I am setting xn is equal to 1.5, and the corresponding differences I will use in my formula. So u value becomes 0. X is xn, that is equal to 1.5. So u becomes 0, and therefore I am going to use the formula without u. Without u, the formula will be used. Now tell me, if I want to find out the derivative at x equal to 1, तो आप क्या करते? What you would have done? If I ask you, instead of x equal to 1.5, if I ask you derivative at x equal to 1, then what you will do?
Set xn equal to 1.
Correct. Set xn is equal to 1 and consider these corresponding differences. So your formula will go only up to del square y. Is that okay?
Del square y.
Yes. Okay. Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So now we will have a problem where x value is in the range. It is not actually given in the table. Okay. So we will solve one problem of that type. I think in the next lecture I can do that. Immediately we will start the next lecture. We will not have the break. Okay.